Welcome back to lecture number 2 of nuclear fission. In this lecture, we are going to study the one important point in your syllabus, that is Bohr-Wheeler theory of nuclear fission. Important point, that is Bohr-Wheeler theory of nuclear fission. In this theory, we are going to study how a nucleus is going to split, or how the heavy nucleus is divide and become into two smaller nuclei, that is explained by Niels Bohr and John Wheeler. This is the one of the important theory. This theory is given by the two scientists, famous scientists, Niels Bohr and John Wheeler. Bohr-Wheeler theory of nuclear fission. Mainly, this theory explains about how the nucleus is going to split and it form into two smaller nuclei. This theory is mainly based on the liquid drop model. The principle of this theory is liquid drop model. Okay, we know that a liquid drop model, it is the one of the famous model given by the scientist Niels Bohr, and in this model he compare the nucleus to the liquid drop. In that first point, in the liquid drop model, we all know that the liquid drop model explain size, shape, mass, and different things of the nucleus. In liquid drop model, we assume that shape of the nucleus is spherical. This is the one of the important point we consider here. Shape of the nucleus is spherical. Okay, now I consider one spherical shape heavy nuclei. I consider nucleus with a spherical shape. Okay, this is, for example, uranium 92-235. Initially, it is in the form of spherical shape. Okay, now we apply external force on this nucleus. The next point here, initially we consider a nucleus that is in the form of spherical. We apply external force. In this, we apply external force. When we apply the external force, that is, it is bombarded with neutron. That means we are going to applying the force on the nucleus. Due to the external force on the nucleus, the shape of the nucleus is changed and it will become spherical to ellipsoid. The shape of the nucleus is changes from spherical to ellipse due to the external force applied on the nucleus. Okay, that is here uranium 92-235 is bombarded with neutron. Its shape is changed. The process of change in the shape of the nucleus is called as deformation. Deformation, here one word is comes, that is deformation. That is very important. Deformation. Deformation means change in the original shape is called deformation. Initially we consider a nucleus, it is in the form of spherical shape. When we apply a force, that is when we apply a nucleus is bombarded with the neutron, its shape becomes spherical to ellipsoid. When shape changes, its surface energy and Coulomb energy are changes. We know that surface energy, Coulomb energy, asymmetric energy, pairing energy in binding energy equation. Okay, here same thing happen. Nucleus spherical shape to it converted into dumbbell shape. Further we increase the force on the nucleus. Further what happens? Further we increase the nuclear, that is force on the nucleus, it will become, it take the dumbbell shape. That nucleus take the dumbbell shape. Okay, here what happened? It will become excited state 90-236. In a last step, further we increase the force. The dumbbell shape is split and it will formed into two different nuclei of nearly equal mass. That is uranium 92-236 is split and it will become beryllium 56 plus krypton 36. This is the theory explained by Niels Bohr and John Wheeler. They simply explain how the nuclear fission reaction occurs. In a simple way, in a step number 1, we consider the liquid drop model. This theory is based on the liquid drop model. In that, we consider shape of the nucleus is spherical. When we apply the force on the nucleus, shape is changes, that is deformation occurs. Spherical to ellipsoidal shape is taken by the nucleus. Further increase the force, ellipsoidal shape is converted into a dumbbell shape. This is step number 3. In a last step, the dumbbell shape, further we increase the force on the nucleus, the dumbbell shape is split and it will form two smaller or two lighter nuclei. This whole theory is given by